Hello everyone! I assume all of you have a Facebook, Instagram or Snapchat account, and even if you don't, you certainly have friends and family, and hence you are part of a social network, which can be visualized as a graph. Here the nodes represent the people and the edges, the connections between them. Now the question is, which people are the most influential? In other words, when I want to spread some information to as many people as possible, to which people shall I pass that information when I don't have time to involve everyone? The authors Ramasuri and Narahari developed an approach to this problem using Shapley values. But what are Shapley values? Shapley values are a game theoretic concept for stating how much an individual player contributed to an outcome. An example would be the following. Imagine you are with 3 of your friends in an escape room. You do really well and escape 4 minutes faster than the average time which is required to escape. But you ask yourself, how much did each of my friends contribute towards this success? Was there even someone who did not contribute at all? The 2 authors used the Shapley values to find out which K nodes are the most influential, where K is set in advance. The higher the influence of a node, the higher is their Shapley value, and hence the most important, or the more important is the node. But how did they do it exactly? First, they modeled the top K nodes problem as a cooperative game NV, where n is the set of nodes in the network. For each subset S of n, they defined a function v as the number of nodes that are connected to the nodes in S, representing the importance of the subset S. Given this cooperative game, the Shapley value is the vector psi, where the individual entries are calculated by this formula, where omega is the set of permutations over n, which means that we look at all different orders of the players, and Si of pi is the set of players appearing before the ith player in permutation pi. The Shapley value psi I is then the sum of marginal contributions of the player over all possible permutations averaged over the number of permutations, which is the faculty of the number of players. Now, the algorithm is the following. Consider the set of omega of faculty of n many permutations of the nodes in the set n. Note that the size of each permutation is n. Then for each permutation x1 up to xn in omega, compute the marginal contribution of each node I using the following expression. Here we apply the function v on the subset up to xi and on the subset up to xi minus 1, and then subtract the values. The third step is then to compute the Shapley value of each node n using the expression from before, which is again shown here. And the last step is to pick k nodes with the highest Shapley values. The solution to the problem is the set consisting of these k nodes. And this was already the whole algorithm that finds the optimal solution. In the end, the authors test their algorithm on a network of collaborating authors, where a node corresponds to a scientist and a link between 2 scientists indicate that they have written at least one paper together. The authors compare their results to the performance of the maximum degree heuristic, and as you can see, the result is great. They have used a second, more efficient algorithm here, where they apply the same procedure as I have shown you, but with a randomly sampled subset of permutations instead of all permutations. Now, that's already it. Thanks for watching this video. I hope you liked it, and the video was made for the course Explainable Machine Learning at the FAU, where Shapley values were covered, and I have chosen the paper presented in this video because I think it shows a nice application of Shapley values. Bye everyone!